Good morning. Welcome to our BGA Rework Station video hangout. And here we like to show you how to rework BGA components. My name is Dennis O'Donnell, Vice President of Precision PCB Services Inc. And this is Mark Capizzi, our Quality Manager. And together we like to help you delve into the world of BGA component rework, including LGA components, QFNs, and any type of high-end packages that need to be replaced on circuit boards. Today we're doing about a 1700 IO CCGA. This is a ceramic column and grid array component. And this is part one. We're just going to be removing the component. After this, we'll have to prep the board. And then these type of components, they usually have a high temp 9010 solder columns. So they'll need to be installed using a solder paste. This particular board is used in aerospace, so we use the lead solder. Most electronics, worldwide now are lead-free. It's done for military space, defense companies that require a high quality interconnect using lead solder stuff. So I'm going to show you a quick demo here. We're using, again, the SV560 BGA Rework Station. Has top and bottom hot air, and it has infrared lower perimeter heating elements. And then it has several cooling fans to cool the machine down faster. So right now, we just, this is our semi-auto machine. The fully automatic ones come with a robotic arm. I prefer the semi-auto. It allows me more space to move around. I can get a true image of the corner walls and corner connections. I think it allows me a little more versatility, a little more true vision. Doesn't cost as much as the fully automated one. And so this is my preference. This is what we're using here, but we do have fully automated systems with a few more bells and whistles available also. I'll give you a little show here. This is our split vision system. Allows us to look at the solder balls on the component and the pads on the board to line them up with split vision. Our SV560 has a high resolution camera and a high resolution screen. And you can see here, this here, right here, is our pickup. It's our pickup tube, and it's sort of in a blue light. And then this is our ceramic component. It's in the yellow light. So we have this lined up in the pickup tube. If all goes well, this will pick up automatically. Sometimes these components are a little bit heavy, and you may have to end up hand picking them up if they don't stick to the cup well. I'm just rechecking my alignment. Make sure we're centered in the pickup tube and centered in the nozzle. And so we're comfortable with that centered now. What we're going to do is to help transfer the heat, allow the component to come up easier. And this will help also for the solder to come up more on the post so we have less cleanup. I'm just applying a tacky flux around the perimeter of the components. And this will help us to pick up the component, or help the component to release easier. So this is quite simple. The unit has touchscreen control, and we simply line up our component, flex it, or it's centered in the bottom here, and we're just going to do a desolder command. The machine will automatically go down. It will sense the height of the component, and then it'll rebound so there's about a 3 millimeter space between the component and the pickup tube. This is the first time we're doing this chip on this machine, so we have a thermocouple in at the solder connections. We're monitoring the solder temperature to make sure it heats up enough and that we don't have to readjust our profile this first time around. I think we will be doing well. So if the profile heats up like we expect, at the end of the profile, the machine will automatically pick up the chip. Having the heavier duty or higher wattage bottom heaters allows us to heat up the whole board more. This will reduce the possibility of warpage. Like I said, if you have a good profile and you have a machine that does good and even heating, you should have no warpage. You shouldn't have the need for any type of fixturing or tooling to hold the board straight. When you have a correct profile, we're trying to duplicate the same process as we would with a reflow oven. The board should not be warping. We're about 4 minutes into the profile. It should take about 3 or 4 minutes to come to reflow temperature. Our profiles are usually set to run about 7 to 9 minutes overall from start to finish. So we're just getting into our fourth zone. This is our final reflow zone. Our solder joint temperature is right now about 194, and we're shooting between, we'd like to see between 190 and 220. And so we're in there on the lower end. And we should be picking up in about 30 more seconds. Our temperature is still gradually increasing, so our board has not soaked up the heat, so our dwell has been set properly. I'm about to pick up, and it's at 202C. There we go. So our suction cup didn't get a good enough grip, so we just lifted it off by hand. Now the machine's automatically cooling. Yeah. So you have these little pickup tubes that they have different sizes that go on the machine. They have little rubber high temperature suction cups on the end. So if you encounter where it's not picking the component up right away, it's time to change the suction cup out. After a little while, they start to harden, and you need to put a new one in that's a little more flexible. Look over here, let it cool down. So again, the machine has a top cooling, bottom cooling, side circuit board cooling as a side fan here. And it also has fans to cool down the infrared heaters on the bottom, so it has rather rapid cooling. We just went from a temperature on the circuit board of 100 or 205C, and the cooling we're down to about 80C right now already. And it roughly takes about 2 minutes to cool the board down. So this is our ceramic CCGA component that we've just removed. You can see it's a ceramic component that's rather heavy. It has column grids on the bottom. And so what we'll do is we're going to install a new component on this board for the customer, and then we're going to reattach new columns on this chip after we inspect it, and then they send it back to them with new columns, and they can do the testing to find out why it's failing. Okay, so our component's been removed. We're going to go and take this board off and inspect it and clean it up and get it prepped. So what we'll do is we'll end this part of the Rework series, and then stay tuned later on today for part 2, and probably about an hour or two, and then we'll be showing you how to place the ceramic BGA back on the board. Thanks for watching.